We're going to go ahead and do problem 34 here, which is f of x is equal to 2x plus 9x. And I'm going to go with all the procedures here, steps 1 through 8, that we want to do. So let's go ahead and start doing it. Now, the first thing we want to examine is that our function is not in what I would consider rational function format. So let's go ahead and rewrite this now over x now. So remember, we would multiply 2x by x over x, and we would get 2x squared plus 9. And we notice that in our denominator, we'll never have a 0, but we will have an undefined part of our domain at x is equal to 0. So let's go through the steps. First of all, find the domain of the rational function. So step 1 was the domain, and interval notation is going to be negative infinity up to 0, union with all the numbers from 0 to infinity. Okay. Step 2 is write r in lowest terms. R is now in lowest terms because I do not have a reducible factor between the numerator and the denominator. So I'll put down in lowest terms as we have it. 3. Locate the intercepts of the graph. We're going to go ahead and figure out what, since f of 0 for a y-intercept does not exist, we're going to say no y-intercept. Okay? And what we're doing is we're solving for when it is 0. And we notice that since there are no zeros in the numerator, there is going to be no x-intercept either. Okay? Now let's remember that the biggest way, or the easiest way we find the y-intercept is we plug in 0 for x. That's all we have to do. We can't do that because it's not in our domain. Now, what's the easiest way to find where our x-intercepts are? Is when we're going to have a 0 in the numerator. That doesn't exist either because no x will satisfy 2x squared plus 9 equals 0. So we've taken that care of that. Number 4, we're looking for symmetry. Our normal test would be to replace x by negative x, etc. We're not going to do that. We're just going to put down here, Mr. Huss is a nice guy. Okay, and let's make sure we spell Mr. Huss correctly. Okay, number 5. Okay, what do we do now? We locate vertical asymptotes. Remember, vertical asymptotes are found when it is in lowest terms and finding any zeros that are in our denominator. So we're locating a VA. So we have a VA at when the denominator is equal to 0, and that would be when x is equal to 0 is the line. That's going to be that one. Finally, step 6 is going to be locate horizontal or oblique asymptotes. We're going to use the step process that we found before. For here, we have 2x squared plus 9 over x. We're going to have to use long division. So let's go ahead and use long division and set that up now. 2x squared plus 9. We're going to divide it by x. We notice our first term, since I didn't write all the terms here, so let's kind of fix that up. Okay, let's go ahead and erase the 9, and we'll say 0x plus 9. So we have all our terms written here. So the first thing too is I'm going to put 2x for that one. I'll get 2x squared. Okay, and that's it. We're going to subtract that. We know what we bring down next is our plus 9, and we have a remainder now. So another way to write this function would be 2x, okay, plus 9 over x. Isn't that amazing? That's what we started with. So we notice that we undid our long division by putting it in factored form. So we know what our oblique asymptote is going to look like now. It's going to be 2x. And that's what we're going to have. So let's just put down an oblique asymptote, OB, ASY, oblique asymptote, at y is equal to 2x. Okay. Number 7, graph R using a graphing utility. Okay. So we'll check that using our calculator. We'll get to that in a second. And then let's graph by hand. Okay. Graph. Now let's graph it first, and then we'll check it with a calculator. So let's start out with our graph. So here we've got. Let's go ahead and let's get rid of this one. Hold on 1 second. Let's erase this. Okay. And let's go into the line mode. Okay. I'm going to go into line mode, and I'm going to go with solid. So let's do our XY axis first. It doesn't want to do that for me. I know there's a way to do it here. Okay. And we'll try that again. Oh, there we've got it. So let's erase these real quick. Okay. Nothing like trying something new. Okay. So here we've got, oops, we didn't want to draw our line. We wanted to go ahead and make a nice line. Okay. So let's make a nice line. And here is our nice line. Here is our nice other line. Okay. I'm going to now throw in a vertical asymptote. My vertical asymptote is going to be right next to my y-axis. Okay. So I'm going to put with a little leader, VA, x is equal to 0. Now, our horizontal asymptote is going to be a little more difficult to do, but let's try it. Okay, let's go back into our line mode. We've got our line, and I'm going to look for a slope of 2. So I'm kind of trying to get a slope of 2. I'm going to go here, and I know I'm going to go something like this, and that's my HA. Not an HA, sorry, it's an oblique asymptote. Let's label this. Okay, so this is going to OB for oblique, ASY, okay, at y is equal to 2x. Okay, now we could go ahead and plug in a couple points and substitute and do that, but here's how I want to do it for starters now. We know we don't have a y-intercept at all. So now I'm going to evaluate limits. Okay, so I'm going to say, what is f of negative 100 going to look like? Okay, it's going to be equal to 2 times 100, negative 100, sorry, 2 times negative 100 squared plus 9 over negative 100. Okay, now another way to look at it would be, is it's going to be along this line, but it's going to be another way would be f of negative 100. Could we also use, it's going to be 2 times negative 100, which is a number, an output, plus 9 over negative 100. Now we notice what we're doing is we're taking our y value and we're subtracting a little bit more. So that means it's going to be somewhere approaching this way, under this line, and not over it. Okay? So let's stop there. Let's evaluate what's happening around 0. So we're going to look at what happens to f of 0 negative. Okay? So when we look at 0 negative, you realize that the numerator, 2x squared, is just going to be then 2 times 0 squared, which is 0, plus 9, and we're going to subtract it by 0 negative. Okay, now we know what happens when we've already defined what happens a number, positive number over 0 negative. And this number then, okay, is going to be negative infinity. Okay, so we're going to see our behavior is going to come around and it's going to come next to and proceed down the vertical asymptote. Okay, so that's my next one. I'm going to analyze behavior around this asymptote. First one is behavior around the line. Now let's go ahead and analyze what f of 0 plus would be. Okay, remember I'm plugging in a very, very small number next to 0. And again, this would be 9 over 0 plus, which tells me that's going to be then a positive infinity. Okay, so my asymptote is going to start going this way. And then let's go ahead and analyze something big like f of 100. Okay, and I think we'll use the non-factored form. So we have 2 times 100, which says it's right near that line, plus 9 over 100. This is adding a little bit to the y, so it's going to take a point that would be, say, for example, here, and moving it above. So I'm expecting behavior to do something like so. Okay, so that's what I would expect to see in my calculator. So let's go ahead and we're going to stop for a second and we're going to see what that does look like. Okay, we're back here, and you notice the only thing I had on my computer now was a TI Inspire calculator. So I decided, okay, well, I better go find a TI. I better find some calculator, and there I did. I graphed it, and I kind of play with the window. You notice the window is not an easy one to find, because if we think about plugging 1 in, just 1, we get 2x plus 9 over 1. Well, that's 11. So if we did a zoom standard window, we wouldn't find it right away. It'd be hard to see. Now, if we did a negative 1, we would see we would have the same thing, negative 11. So this is where you have to watch what your window settings are. And if you need to, plug a few numbers in there. And that would be the way we do it. So that pretty much handles this problem. And hopefully you've learned about it. We'll do another one, and we'll see how we get the answers down the road. Okay, bye-bye.